In our part 1 video, you learned how to do polynomial long division. So we're going to look now at what I might argue is a little bit faster way of doing the same thing. We've done synthetic substitution, and we're going to use it very much in the same way to do division. So just as a reminder, if I wanted to, in this case, divide by, for our long division, when we did our synthetic substitution, I would have said, okay, plug in and evaluate, say, f of 3 in this case. And you would have put 3 and then your coefficients from the highest power down, and if you're missing any, you put a 0 in its place, and then you do your synthetic substitution. The only difference here for division is you're going to be dividing by a, say, x minus 3, x plus 3, x minus 7, something like that. So in order to know what we're synthetically substituting in, I need to set whatever I'm dividing by equal to 0 and solve for x. Okay, so this is a quick reminder of how we did the substitution. Okay, and then whatever I'm left with at the end, just like in our last video, is our remainder. Okay, so then we just have to talk about what I do with these numbers that I have here and how I write my new polynomial when I divide. So let's look at what I have for that one. So we divided by 2x to the 4th minus 5x cubed minus 4x plus 8. We divided that by x minus 3. So when I set x minus 3 equal to 0, I used 3 that I'm synthetically substituting in. And then I went from highest power to lowest, putting in the coefficients. I have a 0 because I'm missing the x squared term. Okay, so then when I dropped the 2 down, we multiplied, add, multiply, add, and so on. So this is what I got at the end. Each of these numbers, the 2, 1, 3, and 5, represent my new coefficients for my new polynomial, the 23 representing the remainder. So since I started with an x to the 4th and I divided out x minus 3, I now have x to the 3rd because I took out an x. And just like in our long division, we get a polynomial plus our remainder over what we divided by. So we're going to try this for a couple here. So I'm going to divide this long polynomial here by x minus 1. So really what that means is when I set x minus 1 equal to 0, I get x equals 1. So I am going to substitute in synthetically 1. Okay, so now take the coefficients of my polynomial, starting at the highest power. So I have 1x to the 5th, negative 4x to the 4th, 3x to the 3rd, negative 5x to the 2nd, 2x to the 1st, and then a 6. So I don't have any missing terms. I'm just going to make that a better 4. I drop the first term, and then I multiply by this 1. So I have 1 times 1 is 1. I'm going to add, multiply by the 1, add, multiply, add, multiply again, add, and multiply one more time, and add. So this ends up being my remainder. These end up being my coefficients of my new polynomial. So since I had an x to the 5th, I now have x to the 4th. Okay, so I have 1x to the 4th minus 3x cubed. I have a 0x squared, so you can put in the plus 0x squared or leave it out, minus 5x minus 3 plus 3 over what I divided by, and that's x minus 1. All right, let's try the next one. All right, so I'm dividing by x minus 2, which if I set that equal to 0 means that I'm synthetically substituting 2. All right, so now from highest to lowest power, I have x to the 4th. I have an x to the 3rd. I'm missing my x squared, so I'm putting a 0 in. Got my x and my minus 4 with no. Drop the negative 3. Multiply. So I've got negative 6, okay, and then add, multiply, add, multiply, add, multiply, and add. So the 2 is my remainder. These are my new coefficients. So I was at x to the 4th. I took out an x. So now I've got a 3x to the 3rd minus x squared minus 2x plus 3 plus my remainder over what I divided by. Now, in order to do synthetic division, I can only divide by an x. Okay, I'm not going to divide by x squared. I would have to do more with it in order to do it that way. So basically, if my suggestion is, if I'm just dividing by a 2x minus 3 or an x minus 1 or something like that, use synthetic division. If it's something more complicated, then use your polynomial long division. All right, I'm going to do 2 more, and then you're going to do example E for yourself and put your answer in when the bubble shows up. So I'm going to synthetically substitute 1 into x to the 7th minus 1. So what I've got here is I've got a x to the 7th, I've got no x to the 6th, no to the 5th, no to the 4th, no to the 3rd, none squared, none to the single one, and then minus 1. Whew. Okay, so I'm going to drop the first one, multiply, add, multiply, add. So I just got a bunch of 1s here. And I get a remainder of 0 in this case. So when I divide, I went from x to the 7th, so now I've got 1x to the 6th, and x to the 5th, x to the 4th, 3rd, so I've got 6, 5, 4, 3, 2, 1, none, so I've got plus x squared plus x plus 1, and since the remainder is 0, I don't have to add anything else to it. All right, one more, and then you're going to do one yourself. So I'm going to synthetically substitute negative 1. I've got negative 4 as my leading coefficient, and it's the 3rd, 2nd, 1, none, so I don't have any missing terms in this case. Okay, so I'm going to drop the negative 4, multiply, add, multiply, add, multiply, add. So this becomes my remainder. So I went from x to the 3rd, and I'm going to go down to x to the 2nd. So I've got negative 4x to the 2nd plus 3x plus 0 plus negative 7 over x plus 1. All right, so at this point I want you to try the last one and put in your answer when the bubble shows up.